lecture 21, right? So in last lecture, we did the two-part test. समझ आया था? Two-part test.
Yes, sir.
Yes, sir.
Yes,
So
sir.
what was that? Summarize. Can you explain?
सर मतलब हमें बेसिकली ऐसी वैल्यू ढूंढनी है जिस पर एग्जिस्ट ना करे, आई मीन यूनिक आ जाए. तो हमने दो मेथड्स किए थे.
हमें दो पाथ ढूंढने हैं. We need to determine two such paths so that the value of the limit along these two paths should be different. That's the key idea. Okay. So we'll do few more questions on that. So we need to check the limit along the origin. We have x plus y upon x minus y. So can you find a suitable path for this? So yes, can somebody find a suitable path for this? Can you suggest something?
Y is equal to m.
Y is equal to
mx.
Yes. So, but you need to show that you need to first ask me ki along which point we want to find that path, because that path must satisfy that point, right? So first of all, I should include in the statement that I want to check the limit at origin. That means at 0, 0. So now your path is valid. Why it is valid? Because the path passes through the point 0, 0, right? So let y is equal to mx. So then limit x goes to 0, x plus mx upon x minus mx. Okay, so eventually we are left with 1 plus m upon 1 minus m. So what will state? Which is not unique, right? Therefore, limit does not exist, of course, at 0, 0. Right? Are you getting this?
Yes.
Okay.
Yes, sir.
Yes, sir.
So let me take. Yes.
सर लिमिट यूनिक इसलिए नहीं है क्योंकि जो m है वो वेरिएबल है, राइट?
So there is a difference between the variable and arbitrary constant. Can you explain something?
Yes, sir.
Can you explain why?
सर वेरिएबल की वैल्यू चेंज होती रहेगी बट आर्बिट्री कांस्टेंट हम एक ही बार लेके और फिर उसी के साथ सॉल्व करते हैं.
That's true, but let me complete the statement. हम इसे ऐसे बोलेंगे कि within the problem, if some variable is changing its value, then if some quantity is changing its value within the problem, then we call it as a variable. But if we change the problem and the value changes, then we call it as an arbitrary constant. Okay, so let's say if you define the value of m to be 2, then for one straight line m will be 2, right? So if you take the value of m will be 2, then there is one particular line along which the value of m will remain same, 2, right? But value of y and x will keep on changing in that problem as well. But if you take next problem, value of m will be 3, let's say 3, 4, 5, anything, let's say 5, right? So for that one straight line, value of m is fixed, that is 5. But if you change the problem, of course, your value will be changed. But in that one problem also, y and x will keep on changing their values. So within the one problem, if the values are changing, then we call it as variable. And if the value changes from problem to problem, we call it as arbitrary constant. And if value doesn't change along any problem, then we simply call it as a constant. Is it fine? So next time when you say that the value is not unique, then you must say that value is not unique because m is arbitrary constant rather than saying m as a variable.
Sure, sir.
Okay,
got that. Yes, sir.
Okay, so we have next question. F of xy, again we'll be checking the limits along the origin. So can anybody suggest some path?
Y equals mx square.
mx
Yeah.
square
बट
y
सर
equals to
लिमिट क्या है?
Along origin, right? The same thing. So now you know that this is passing through 0, 0,
Yes, sir.
Yes sir.
right? This is the family of parabolas which is passing through 0, 0. Okay? Is it okay? So limit xy goes to 0, 0, x4 minus y square upon x4 plus y square. So choose this path. So this will become limit x goes to 0, x4 minus m square x4 upon x4 plus m square x4. So limit x goes to 0, 1 minus m square upon 1 plus m square. In fact, we do not need this limit now, right? So this is simply 1 minus m square upon 1 plus m square. So with the same argument that you are getting the different limits, so limit does not exist at that point. Is that right?
Yes, sir.
Let's see question number this 35. So I'm doing the exercise number 12.2. Okay. So I'm taking questions from it. So f of xy is equal to minus x upon x
Which
square
book, sir?
plus y square root. Right? Now, can you find something? Can you find some path over here?
Sir, y equal
y
to
equals
x.
to mx.
Makes.
Y
Yes,
equals to
sir.
mx.
Will it work?
Equal to mx.
Yes, sir.
Yes
Sir.
sir.
Okay. So I'm just leaving it. So sometimes question can be done through the polar coordinate as well. So most of you have done the polar coordinate, right? In your +1, +2. So while putting x is equal to r cos theta and y is r sin theta. So have you done the polar coordinate?
Yes, sir.
Yes,
Yes sir.
Right?
Yes, sir.
Yes, sir.
Okay. So suppose these questions can also be done by using this. So I'm just doing few of them. So one way is you put a path, right? Y is equal to mx. That is straightforward. Okay. So by putting y is equal to mx, you will come to know that this limit does not exist. Another way is you may use the polar coordinate as well. Okay. So let's say how. So put x is equal to r cos theta and put y is equal to r sin theta already there. Okay. So now if you put that r cos theta and r sin theta, so what will happen? So of course your r will go to 0. R square cos square theta minus r square sin square theta upon r square cos square theta plus sin square theta, which is 1, right? So this becomes your limit r goes to 0, r square cos 2 theta upon r square, right? So limit r goes to 0, cos 2 theta. So now, can you tell me कि इसकी वैल्यू क्या आएगी? Can anybody tell?
1.
Sir, 1.
Anybody?
Yes, sir. 1.
1.
R तो है नहीं इसमें.
Exactly. R तो इसमें है ही नहीं है. फिर देखो, R है?
No, sir.
नहीं है ना? So इसका मतलब क्या है? कि this value can have any value between -1 and 1. Okay?
Yes.
Which can take any value from -1 to 1.
Sir.
Right?
Sir,
हाँ,
ये
मैं अभी
चीज
आ रहा हूँ तुम्हारे क्वेश्चन पे. हाँ, अब बोलो तुम.
सर ये चीज जो हम बोल रहे हैं कि -1 से 1 जा सकते हैं, सर ये तो हम डायरेक्टली पोलर फॉर्म देखते भी बोल सकते थे.
किसमें?
सर जैसे सर एक मिनट पिछला पेज कीजिए, एक मिनट. हाँ सर, यहाँ पे हमें पता है x0 y0 है और हमारा r टेंडिंग टू 0 आ रहा है। सर हम कुछ
हम्म
भी डाले 0 इक्वल टू 0 रहने वाला है ना।
नहीं, मैं समझा ही नहीं तुम्हारी बात।
जो x इक्वल टू r cos थीटा लिखा है उसमें r टेंडिंग टू 0 है हमारा, और
नहीं
x
नहीं,
और
ऐसा
y।
नहीं, समझो यहाँ गलत हो तुम। ऐसा है ना कि ये इसके अंदर जाएंगे, उसके बाद ट्रांसफॉर्मेशन होएगा। मैं इन कोऑर्डिनेट, इन पॉइंट्स को नहीं बोल रहा हूँ,
अच्छा ओके। अच्छा
मैं
हाँ सर।
इसकी बारे में बात कर रहा हूँ ना।
ओके।
ऐसे तो फिर मैं इस एक्सप्रेशन के बारे में कभी बात ही नहीं कर पाऊंगा।
हाँ
समझ रहे हो?
ठीक है सर, हाँ
सो
सर समझ गए।
यू आर टेकिंग अ ट्रांसफॉर्मेशन एंड यू आर टेकिंग दिस ट्रांसफॉर्मेशन इनटू योर फंक्शन,
ओके।
जिसकी तुम लिमिट लेना चाह रहे हो। ओके,
ओके सर।
मैं एक्चुअली एक और क्वेश्चन एक्सपेक्ट कर रहा था। एनीबॉडी?
सर
यस।
सही, ये तो बेटर मेथड है क्योंकि हमें जो आर्बिट्ररी जो नंबर आ रहा था जैसे 1 प्लस एम स्क्वायर एम स्क्वायर, उसकी वैल्यू भी पता चली हमको कि वो cos 2 थीटा के इक्वल है।
हाँ हाँ हाँ। तो वहां ऐसा कुछ नहीं है। बेटर मेथड इन अ सेंस तुम ऐसा कह सकते हो दैट यू आर एक्चुअली विजुअलाइजिंग that your limit will come out to be -1 to 1, but yes, but our ultimate aim was, if it doesn't exist, then we don't care that much कि वो क्या आ रही है। जब वो अलग ही हो गई तो बात खत्म हो गई, right? Because we have a aim to check that whether it exists or whether it doesn't. So we'll conclude over there. Can anybody explain that why I didn't take theta to go, theta goes to 0?
सर अगर दोनों एक्सप्रेशन x और y 0 है तो cos थीटा भी 0 है, एक से आ रहा है cos थीटा 0, एक से sin थीटा 0। सर फॉर द सेम वैल्यू ऑफ थीटा दोनों सेम नहीं हो सकते, इसलिए r 0 होगा और थीटा।
You, this is, you can think it in another way. वो ऐसा है कि जब तुम लेते हो r cos theta, r sin theta, so theta is your characteristic, which is the angle made by this line, and if this is the point over here with the x-axis, यही होता है ना theta, and it can have any choices of the theta. But if you, let's say you want to go to the point 0 0, right? So the only thing you want that your this r should go to 0. You don't need theta to be 0, because if your theta is 0, then of course you may reach over here as well. यहाँ आ जाओगे ना तुम x0, ये भी तो theta 0 वाला point ही हुआ। Are you getting this?
Yes, sir.
So if you take theta to be 0, that theta 0 doesn't take xy to the 0 0 point. So xy will go to the 0 0 point only if you take r to be 0. So that's why we are taking the limit r to be 0 rather than saying theta to be 0, because theta 0 doesn't make it 0 0. Are you getting this?
Yes, sir.
That's why. Okay, so that's why in this question I've taken theta, I have taken only r going to the 0. So 2x, sometimes this polar form may help you when the things are not that much straightforward. Then you can take this, you can take the help of this polar form as well. Xy goes to 0 0. Okay, let me put this expressions here. Yeah, is it okay? So now if you take x to be r cos theta and y to be r sin theta, and let's make the expression again 2r cos theta upon r square cos square theta plus r cos theta plus r square sin square theta. So this becomes limit r goes to 0, 2r cos theta upon this r square and r square cos square theta plus r square sin square theta will be transformed to r square plus r cos theta, right? So now if you cancel the r from the expression, then this will become what? Limit r goes to 0, 2 cos theta upon
R plus cos theta.
r plus cos theta. Okay, so now you will have 2 cos theta upon cos theta, right?
Yes, sir.
Am I
Yes,
right?
sir.
Yes, sir.
Yes,
So
sir.
what about the value of this thing?
2.
2.
Hmm. But there is one problem.
सर अगर cos theta भी 0
सर
हो जाए फिर
थीटा जीरो
Exactly,
हाँ cos
exactly.
Yes,
थीटा
sir.
0 हो जाएगा
Yes,
जब
sir.
Exactly, right? So you say that limit will not exist if your cos theta is 0, and it can have a multiple values for that, right? Theta should be an odd multiple of pi by 2. Then this
yes
limit
sir.
will not exist. So precisely we'll say that this limit doesn't exist. Okay? Right? Because in
Yes, sir.
every scenario we cannot say that the limit exists, right? Is it fine?
Sir, can you move to previous page?
Yes, yes, please.
Excuse me, sir.
Yes.
सर मतलब हमें पता कैसे लगेगा कि कौन सा मेथड यूज करना है फिर?
देखो, इन मोस्ट ऑफ द केसेस तो पहले वाले बड़े आराम से दिख जाएंगे तुम्हें, और अगर वो नहीं दिखेंगे जैसे इस केस में है, then you should go for that r and theta rule. Next topic is partial derivative. So have you heard about the partial derivative?
Yes sir. Yes
Yes.
sir.
किया हुआ किसी ने?
सर वो कर्व का सेंटर निकालने के लिए यूज करते हैं शायद एक.
Okay. So can anybody explain what is partial derivative? How it is different from the derivatives we are actually using?
जब मल्टी वेरिएबल होता है तो एक वेरिएबल को कांस्टेंट मानते हैं एंड एक पर्टिकुलर वेरिएबल के टर्म्स में डिफरेंशिएट
Right.
करते हैं बाकियों को
Right,
एंड लाइक हर
right.
वेरिएबल को फिक्स करके हम करते हैं.
Right. So can you explain it a bit geometrically?
सर जैसे अगर किसी फंक्शन को डिफरेंशिएट करना है तो पहले उसको लाइक z को डिफरेंशिएट करना है तो पहले उसको y के रिस्पेक्ट में करेंगे, लाइक एक को कांस्टेंट पकड़ के दूसरे को ही करेंगे बेसिकली डेल.
That's true. But I'm asking a different thing. मैं ये पूछ रहा हूँ कि ये जो keeping constant, the word you are saying that the keeping constant, okay, so that keeping constant means what?
सर कि उसके रिस्पेक्ट में कितनी मतलब फास्ट चेंज कर रहे हैं कितनी स्लो शायद.
No, you are keeping the constant. You keep taking x to be constant. You are taking y to be constant. So can you tell me कि वो geometrically उसका मतलब क्या है? Okay, so let me define this. Okay, so first of all we'll define it theoretically, and then we'll try to find a geometrical interpretation. Try to see the things, visualize the things. Okay, so partial derivatives. So let's say what? So let z is equal to f of xy be a function, then partial derivative of f of xy with respect to x at x naught y naught is defined as, इसको हम लिखते हैं ऐसे इस नोटेशन से, ये तो याद होगा ना. I'll be calling it as
Yes sir.
curly f upon curly x. Okay, so that would be nothing but simply taking the derivative of f and you keep your y constant. That's what it means, huh? At point x is equal to x naught, right? Am I right? Okay, so if let's say if I want to write it in terms of limit, so I would write it as limit h goes to 0 f of x naught plus h y naught minus f of x naught y naught upon h, right? This limit should exist. Am I right? This limit should exist. Okay, are you with me on this?
Yes, sir.
Right?
Yes sir.
So let me call this as x-axis, this as y-axis, okay, and this as z-axis. So let your y naught is somewhere here, okay. So let's your y naught is somewhere here, okay. तो अभी चलो अगर या इट्स फाइन, तो क्या करना है तुमको, जहां पे y naught है वहां पे we'll draw a line sort of new z-axis, right? And then you try to find out new x-axis, okay, right? तो अब see this, so there is a 3D surface, okay. Are you listening to me?
Yes, sir.
Everyone? Okay.
Yes.
So now if you suppose there is a whole surface, right? Right. So if you keep your y fixed, what will happen?
XZ प्लेन में बनेगा जो भी बनेगा,
xz प्लेन में बनेगा जो भी बनेगा, तो xz प्लेन में क्या बनेगा?
जो उसका डेरिवेटिव है वो प्लॉट प्लेन में होगा।
एग्जैक्टली। तो अब इसका मतलब जो एक तरह से होगा क्या कि ऐसा समझो कि we'll slice this and we'll take a curve out of it, इसी शेप की, right? So that curve will look like ऐसी, सिर्फ इस कर्व की बात करेंगे। Are you getting this? Are you getting this? Anyone?
Yes, sir.
Anyone?
So repeat कर दो एक बार.
So, yeah, that's what I'm saying. Let's say, let's say this is a plane. This is your plane along y naught. Okay. तो अगर इससे एक तरह से स्लाइस करो, let me choose a different color. Yeah. So if you slice through this, okay. So let's suppose that this whole thing, the kind of square I'm drawing, okay, and this is, you want to slice it, you want to slice that green solid with this red square which I have drawn, okay. So it may not be square in reality, I'm just trying to say you this, imagine the thing. And then if you are slicing it, so when you slice it, this blue curve will come out. Am I right?
Yes, sir.
Yes,
Am I
sir.
right? Okay. So let's say if you take a if you take a piece of bread maybe, तो ब्रेड को हल्का सा बेंड कर लो, बेंड कर लिया, राइट? बेंड करके अगर तुमने उसको एक नाइफ से स्लाइस किया, तो एक सामने जो शेप बनेगी स्लाइसिंग की, सिर्फ वो शेप लेनी है, मतलब उसको सिर्फ 2D में इमेजिन करना है, 3D में नहीं, राइट? व्हाई? बिकॉज योर वन डायमेंशन गॉट फिक्स्ड, वो क्या हो गई, y नॉट ही हो गई। समझ आ गई ये चीज? और अगर मान लो x फिक्स रखा होता तो क्या होता? इफ यू कीप योर x फिक्स, सो लेट्स से you keep your x fixed, this is your x naught, okay. So this is your x naught, true. So your x naught is fixed, that means this will be like, this is along this line. So if your x naught is fixed, let's say you draw a line parallel to the y-axis here, right? Can you see this?
Yes, sir.
And then you take a line along z-axis over here, okay, and now your new square would be like this, right? And if you cut the bread piece along this side, then of course you will get a different shape, and that shape will look like this thing, Is it okay?
Yes, sir.
Now, that's your blue part. If you see the blue part, only blue part. Now, the blue part will be in the 2D form, इस तरह से. And now we can easily talk about its derivative, right?
So please switch to the previous slide.
Let me finish with this. Okay. So if you can also talk about the blue part, and if you want to talk about the, let's say, pink part, so that is also something which you can draw and which you can talk about, and this is something only this part. Okay. Am I right?
Yes,
Are you
sir.
getting this?
Yes, sir.
So now you can easily talk about the derivatives. You know, for here, if your y is fixed, you'll always talk about x versus z, right? And if your y is fixed, then you talk about x versus z. And if your x is fixed, then you always talk about y versus z. Am I right? Am I clear now? ठीक है?
Yes, sir.
बात समझ में आ रही है?
Yes, sir.
Okay. So is it fine now?
सर
हाँ जी बोलो.
सर जो प्लेन कट किया है ये वही निकाल के आपने रख दिया ना?
हाँ वही निकाल के रखा. उतना कर्व निकाल के रख दी बस वहां से. प्लेन भी नहीं, कर्व निकाल के वहां पे रख दी.
जो कर्व कट हुआ है उसमें.
हाँ वो कर्व. तो एक बार एक साइड से कर्व निकली ब्लू वाली, राइट? और दूसरी बार क्या निकली? पिंक वाली. वो थोड़ी छोटी अलग शेप की निकली. हाँ, तो कोई और शेप बनाएंगे, कुछ अलग तरह की निकलेगी. ट्रू?
यस.
So similarly, we can define the partial derivative of f with respect to y at point x naught y naught, which is equal to derivative of f keeping x fixed and taking the derivative of f with respect to y at point y is equal to y naught. This is the same thing if this limit exists. That means limit h goes to 0, f of x naught y naught plus h. So, and then we'll subtract f of x naught y naught from this expression upon h. So we'll do one more example and then we'll conclude the lecture. So example is, find the partial derivative of this f with respect to x and with respect to y at point 4 minus 5. So taking curly f upon curly x, which is equal to, of course, 2x plus 3y. So if you put the point 4 minus 5 in this, so you will get 8 minus 15, which is minus 7. So now we differentiate f with respect to y, which is equal to, if you take the derivative of x square with respect to y, that would be 0, and derivative of 3xy with respect to y would be 3x, plus derivative of y with respect to y is 1, and minus 1 is constant, so its derivative would be 0. So now if you take curly f upon curly y at 4 minus 5, so you don't have y in the expression, so you put x is equal to 4 over here, so it becomes 12 plus 1, 13. So you got the idea? You got how it works, the partial derivative stuff?
Yes.
Okay.
Yes, sir.
So that's it for today.